Today we're looking at finding an inverse for a given function. So here's an example. Consider this function f of x is x plus 1 divided by x minus 2. To find an inverse, we need to do two things. First, we need to make sure there is an inverse. Functions that are invertible. Oh no. A? I? Oh no. Okay, sorry, that's gone badly. Okay, I don't remember how to spell the word. That's okay, it's not English class. Functions that are invertible are called one-to-one. One-to-one means that the idea of a function, so passing a vertical line test, if we swap x's and y's, that still happens because that's what the inverse would look like. So to test for this, we use a horizontal line test. I'm gonna hop over to the graph here. Here's the graph of this function. Again, maybe it's a little bit different than things that we're familiar with, but if I look at horizontal lines along this graph, what I'm looking for is that we only hit the graph one time. Everywhere through here is certainly fine. Everywhere up here is okay. The one place we might be a little worried about is right there. But if you look at the edges of the graph, you should notice that what's happening is that the curve itself, the function, the red, is approaching, it's sort of squeezing into that line, but doesn't ever actually cross or intersect it. So at that value at y equals 1, we actually don't get any intersections at all with this horizontal line. So it certainly doesn't hit it more than once. So is it one-to-one? Yes, because it passes the horizontal line test. Meaning that if we invert, or in other words, sort of reverse the process of how x pairs to y, if we go back the other way, we'll get a thing that's still a function. That's what we're really testing. To actually find the inverse then, remember that's what this notation means. F with this -1 superscript means the inverse of f. To find the inverse, I'm going to delete this now because I'm embarrassed. Okay, we'll just forget that ever happened. To find the inverse, we take the function. So here's our original function, x plus 1 over x minus 2. And we swap x for y. So wherever there was a y before, we write an x, and vice versa. Notice I also, keep in mind that f of x is interchangeable with y. I went ahead and did that. So I rewrite this as x equals y plus 1 over y minus 2. This describes the inverse relationship. Since we want it as a function, and what we did up here is verified that there is such a function that does this. Since we want it as a function, what we're going to do now is solve this for y. So I'm going to take x equals y plus 1 over y minus 2, and I'm going to solve that for y. So let's start with this. This thing is a fraction. I'm trying to get y by itself. The first thing I'm going to do then is clear it out of the denominator. So let's multiply both sides by y minus 2. Those cancel. So y minus 2 times x equals y plus 1. Now again, what I want to do is solve for y. I've got y's on both sides of the equation now, so somehow I'm going to need to collect all the things with a y to one side and get everything else to the other. Because of this multiplication here, I'm going to distribute. So xy minus 2x equals y plus 1. And then I'm going to get all the y terms to one side and everything else to the other. So I can subtract y to move this over, so that I'm gathering y's on the left-hand side. That means I'm going to move everything else to the right-hand side, so I'm going to add 2x to both sides at the same time. So I've got xy minus y equals 1 plus 2x. Okay, this is where things maybe get a little bit weird. These are like terms from the perspective of y, because they both have y to the first in them, right? So they're like terms, but I have x minus 1 y, and I can't combine those because the coefficients aren't like things. So what we do instead is factor it out. So factor the y out of that, xy minus y. I can factor that as x minus 1 times y. The reason I'm doing that is so that I can get rid of it. I want to get y all by itself, figure out how many y's there are on the left-hand side. Well, there's x minus 1 of them, right? And unfortunately, I can't really make that look any nicer than it does, but that's sufficient because it gives me a thing that I can divide out then to solve for y. I've got y equals thing involving x. This is our inverse then, which I'm just going to write as the inverse of f is 1 plus 2x over x minus 1. So given this function that we started with, which we verified as 1 to 1, we swap x and y, then we solve for y, and that gives us our inverse function here. Okay, hope that's helpful. The general idea here, sorry, wrong thing. The general idea here, this is how you always find inverses. I wanted to look at this one in particular because a couple of these algebra steps in the middle are a little bit, you know, feel a little strange maybe the first couple of times you see them. So I wanted you to have this to refer to take a look at that. In a lot of examples, finding the inverse, that this part solving for y is not as complicated as what happened here. So I wanted you to have this to go back and look at. Okay, hope that helps. Let me know if you have questions, please.